We have seen radiation, conduction and convection. Now we will discuss a little bit about radiation. So, radiation means you do not need any medium actually. If it is coming through medium also, medium will not be heated. For example, I said already example that airplane moving at 10 kilometer above the earth's surface, their temperature minus 40 degree, all the sunlight will be there. So, air is not getting heated up, that is why temperature minus 40 degree, but near earth temperature is higher because of convection, earth's surface will be heated up because of radiation. So, that radiated heat will be heating up the nearby air molecule. So, that is why this earth surface temperature 30, 35 degree, 40 degree will be there. But if you go up from the earth surface, the temperature goes down, although solar radiation already there. So, solar radiation is not hitting the air, it is hitting the earth surface. Okay. So, it is not hitting the medium. Okay. It is passing through the medium, but not hitting. So, it vacuum also it can transfer. So, it is actually electromagnetic energy. So, radiation basic formula is that Stefan Boltzmann formula Q equals epsilon or E sigma A Ts power 4 To power 4. So, the sigma value, sigma actually is Stefan Boltzmann constant 5.67 10 power minus 8 watt meter square K4. So, those units also you have to remember and constant, because this is universal constant. So, you should remember, you should not forget these values and units. Okay. Absolute temperature of surface Ts in Kelvin. So, this temperature is given in Kelvin actually, okay, not Fahrenheit or Rankine. So, here it is Kelvin temperature. Absolute temperature for surrounding To, okay, let us say this is heated up, this is Ts and surrounding temperature To. Okay. Surface emissivity, surface how much emissivity is there. So, you can give some value. If it is black body, it is 1. Okay. If it is not black body, so in problem sometime I will give a black body. If I write, then actually you have to assume 1. So, in that case I will not give emissivity value, but if I do not give that black body term, then I should give emissivity value. Okay. Emissivity value should be 0 to 1 if perfectly white body reflecting. So, in that case actually emissivity should be 0, and if it is absorbing, so black body, it is 1. Surface area A meter square. Okay, is everything given in SI unit, not in your field unit. So, you see one problem, a body kept in a room temperature 27 degrees centigrade room temperature, given data, emissivity of the body 75, surface area 300, temperature 227. Calculate initial value of the net power emitted by the body using the Stefan Boltzmann's law. Okay, so this directly you can use the formula Q E sigma A Ts power 4 To power 4. So, E value is given 0.75, sigma value given, and Ts value, sigma value is there, and what is 300, A area centimeter. Okay, area is centimeter, so you have to convert it into meter. Okay, 300 divided by 100 power square. Okay, so it is becoming 300 into 10 power minus 4. Okay, so that value is given here, fine. And centigrade temperature is given, so 27 degrees centigrade is given plus 273. So, it is giving 300, okay, and 227 is given. So, 227 plus 273 equals 500. Okay, you are converting into Kelvin, centigrade to Kelvin. So, this is Kelvin actually, so do not forget. Okay, if you are putting another unit, it will be completely wrong. So, it is becoming 69.4 watt. Okay. This is a very simple problem, you should remember this, especially this Boltzmann constant, how to solve the problem, what the data required. So, you should remember the formula also. Okay. And for further study, you should go to any undergrad textbook. Okay. So, when you take certain amount of ice, you increase temperature, let us say ice minus 1 degree centigrade temperature. Okay. You increase temperature, then it will be liquid after certain time. Then again you increase temperature, it will be evaporating, or it will create loss of steam. Okay. So, what happens, you minus 1 degree temperature is there, you increase temperature, so that time it will be ice only till it reaches to 0 degree centigrade temperature. Okay. So, 0 degree centigrade temperature, although you are adding heat, x axis if you see heat added, although adding heat but temperature not increasing. Okay. So, what is happening that time ice will be melting, okay, from solid to liquid. So, it will be taking lots of energy and molecular change will be happening, okay, physical change not chemical change. So, that time temperature not increasing. So, you are doing everything in constant pressure. So, you are assuming normal atmospheric pressure. Okay. So, that heat is taken during melting is called latent heat. Okay. Latent heat, latent means hidden, okay, hidden heat is there. So, some amount of hidden heat it will take. So, it will not, you cannot sense using your thermometer, okay. But if you have anything to measure like heat, how much you are giving. So, if you have any instrument, so then you can measure heat is giving, you are giving heat and you can measure that one. But temperature thermometer will not show any increase in temperature, it will show only 0 till it completely melts, okay. Then again it will start increasing, thermometer will show increasing temperature. So, increasing temperature, it will reach to 100 degree centigrade, okay. So, again everything is happening at 1 atmospheric pressure. If you changing pressure, then story will be different. So, assume initially 1 atmospheric pressure, okay. So, at 100 degree centigrade it will be start boiling, again temperature will be fixed although you are adding heat, okay, no change, temperature no change although you are adding heat. So, this is called latent heat again, latent heat of boiling. So, previously it was melting of ice, it was latent heat of fusion or melt, fusion or melting you can say, latent heat of melting, latent heat of fusion, or latent heat for solidification. In opposite way you can say 0 degree water you take and you cool down, you remove heat, okay. So, some amount will be heat will be, it will be taking, but will be kept hidden. When it is boiling also it will take certain amount of heat. So, liquid means more molecular cohesiveness, more molecular attraction. When it is you are making it is steam, so that means you are giving so much energy so that they will not be able to touch each other, they will be moving randomly. When steam or gas, when you are talking about molecular motion will be higher, okay. So, Brownian motion will come, but you are reducing temperature, you are making liquid. So, Brownian motion will not be playing such role because liquid more viscosity will be there. So, fluid will not be moving. Rather, if you are changing 0 degree to 100 degree centigrade water temperature, molecular resonance will change, okay, molecular resonance or molecule will be vibrating more. But when it is crossing 100 degree, so that time vibration will be so high, so it will not be touching each other or it will not have any attractive force, rather it will be moving away and randomly moving here and there, okay. So, that is called latent heat. Again after 100 degree centigrade temperature, if you are increasing giving more heat, so it will be going to superheated region. Heated, okay, superheated region means 100 degree at what atmospheric pressure you are giving more heat than the steaming temperature or 100 degree centigrade, okay. So, that is why this is called superheated region. So, if superheated some steam is there, if you want to make liquid, so first you have to reduce temperature to 100 degree centigrade, then it will be starting creating liquid, okay. And some values are given, so you should try to remember latent heat of fusion 334 kJ per kg, then liquid heat capacity 4.2 kJ per kg. So, these values are important, that is why I have given this picture. I have given from I have taken from this picture from Wikimedia, okay, because of these values are important, okay. 2265 latent heat for vaporization, and this is every time we have to say in atmospheric pressure. If you are changing at pressure, then story will be different. For example, your pressure cooker normally it will be working at 2 bar pressure, then it will create that high steam, that sound will be coming, right. So, the temperature will be 120 degree centigrade about 2 bar pressure. So, if you are changing pressure, then your boiling temperature will change, your melting temperature will be changing, okay. So, if you are applying pressure on ice, so it will be melting at normal temperature also. So, for example, you take 2 ice and pressurize, it will melt, again release the pressure, it will be joining actually. So, joining means the normal temperature you melted, again you release pressure, that whatever water you melted, so that one will be ice again. So, it will be fusing together, okay. So, if you change pressure, so your melting and boiling temperature, boiling condition also will be changing. Okay. So, already we discussed about viscosity, the whole whole course actually we have used the term viscosity several times. Almost every lecture there will be term viscosity, viscosity, density, because oil and gas when you are talking about, so you have to play with viscosity, density, temperature, pressure, right. So, because it is lecture on heat transfer, so you have to know that viscosity is related to temperature. So, if you are changing temperature, viscosity will also change. Okay. So, viscosity definition also you must remember, it is resistance to flow. So, if you have higher viscosity, particle will not try to flow easily. Okay. Viscosity in gas, molecules transferring momentum, because this Brownian motion will be there. So, if you are increasing temperature, what will happen? Particle will be moving more. So, actually when it is moving more, viscosity will increase. Okay. But in liquid, it will be weakening the molecular forces. So, in that case viscosity will be going down if you are increasing temperature, but in gas it will be happening opposite, because molecular randomness will be increasing, it will be colliding more. So, there will be more viscosity. Okay. So, gas in temperature increases, gas molecular interchange viscosity goes up. Okay. So, molecule will be transferring momentum and viscosity will be going up in gas, but in liquid just opposite will be happening, because molecular attraction forces will be reduced because of temperature, they will be forcing, do not go to nearby. So, in that way viscosity will decrease. Okay. So, further details go through your any book of viscosity, undergrad textbook. Okay. And now some more thing you have to remember is thermodynamic laws. So, in class also many time I ask the student how many laws are there. Many students will be saying 3, many students will be saying 4. Actually there are 4 laws. You see the 0, first, second, third. So, 0th law, first law, second law, third law. Okay. So, 0th law says like thermodynamics, thermodynamic equilibrium, A equilibrium with B, B equilibrium with C. So, C will be equilibrium with A. So, this is the rule of 0th law, right. First law thermodynamics says work and energy definition. Work can be converted into energy. Okay. Second law says entropy concept. They are saying work and energy can be convertible, but there will be certain energy loss every time. Okay. So, there will be no perpetual motion machine. Perpetual motion machine means you design any machine, so that will be running automatically continuously without supply of any external energy. So, that is not possible, never possible. So, this whole perpetual motion machine is never possible. Okay. So, you transfer heat from your heater treater to another system, and you are thinking same heat will be taking back and you will be giving to feed. So, that is not possible. External heat supply of some energy you must be giving input every time, because there will be certain losses which you cannot get back from the system. Okay. So, second law says that entropy concept and irreversibility. Okay, when whatever machines we are running, normally they will be irreversible, some energy will be lost. Okay. So, reversible means some process is going A to B, so B to A again you are coming, there will be no energy loss. But normal machines like say air conditioner running or your camera running or TV running, computer running, anything, so there will be certain energy loss you cannot get back, never. Okay. So, that is called irreversibility of process. Third law says entropy of perfect crystal at a temperature of 0 Kelvin, absolute 0 is equal to 0. Okay. So, this is absolute 0 definition will be coming from third law. And there are two statements from for second law, actually closest statement, the heat can never pass from colder to warmer body without any work. Okay. So, that is why this your refrigerator systems are there. So, some mechanical energy must be giving input. So, then you can transfer heat from lower body to another higher body, higher temperature body. So, Kelvin-Planck statement, it is impossible to construct a device that operate in a cycle and produce no other effect than production of work and the transfer of heat from a single body. So, actually these statements is like perpetual motion machine not possible. Okay. So, this basic definition you should remember, because you are trying to learn basically fluid mechanics and machines interaction. So, in that case you have to know definition of work, power, energy, you have to know the thermodynamic laws, you have to know viscosity, you have to know density, these definition, those are basic things for your petroleum engineering related subjects. Okay. You cannot ignore. Okay. During interview also you should remember those basic things, units, definition of thermodynamics, basic heat transfer. Okay, so you should recap. I cannot teach everything in this course, but you should recap from other textbooks. Okay. So one example is given what the difference between first law and second law. So many times I ask many students about difference between first law, second law. They'll be giving mechanical definition. You can remember this Three Idiots movie. So one mechanical definition, one is practical definition. So we expect sometime practical definition, whether you understood or not. Many students will write like del S greater than equals 0 for universal entropy increasing in second law, or Clausius statement as it is, they'll be remembering. So we don't want, sometimes we ask whether you understood or not. Okay, so one simple example they have given, like say if a cup is falling from the table, it will break. First law says it will come back, it will be joining again. Second law says not possible. Second law says some energy lost, you cannot get back, so it is not possible to join again. But first law says like it will fall down, it will break, it will come up, it will jump on the table, and it will be again cup. Okay, so that is the difference. Okay, first law says convertible possible, second law says 100% not possible. Fine. Definition of some definition like entropy, enthalpy we use several times in your calculations. So you should know the definition. So basic definition you should remember. Enthalpy, like measurement of energy. So how much energy is there in a body? Okay. So a formula is that H equals E plus PV. Okay. E is internal energy, P is pressure, V is volume. Okay. So many times we use this enthalpy term to calculate. Entropy, thermodynamic function used to measure the randomness or disorder. This is also actually energy. Okay. Heat definition is that energy transfer from one body to another body if delta is there. Okay. This is also energy. Heat is energy. Okay. Temperature is not energy. This is measurement of heat or physical quantity to express the coldness or hotness, you can say, not measurement of heat. SI unit of temperature, Kelvin. But if you are using other type of unit system, for example field unit and other, so you will have different units, but for SI we use Kelvin and Joule for heat. Okay. Thermodynamic process, few processes you should know. Adiabatic process. Adiabatic process means like you take certain system and heat is not going to transfer anywhere else. Okay, we are assuming all heat are inside system, so you are compressing something, decompressing something, you are not changing heat, so that is called adiabatic process. So no heat transfer happening, so heat is not changing. Temperature can change, heat is not changing. Okay, you are not going to waste your heat. Isochoric process, no change in volume. Okay, so the term you should remember, isochoric. Okay, so no change in volume is not changing, but other parameter may change. Isobaric, bar means pressure. Okay, so isobaric, when you are saying iso same, bar pressure, same pressure system means no change in pressure. Okay, so temperature and other parameter may change, but you are not changing the pressure. Isothermal, therm again you are saying, therm is temperature, so no change in temperature. So no change in temperature means make process so slow that heat will be dissipated and you are maintaining temperature. Okay, so that Boyle's law you can remember, PV equals constant. Okay, so PV constant, like if you are making very slow process, so heat will get dissipated from the system. Let's say this is piston and cylinder and you are compressing this one, this is gas. Okay, this is piston, cylinder, okay, and this is gas, you are compressing. So you are changing pressure, so volume changing. Okay, so this is you are moving, okay, you are compressing. So what will happen, it will be getting compressed, volume will be changed. Now temperature will also get up, but if you are making system so slow, the temperature will get dissipated, heat will be getting dissipated, so temperature is maintaining. So in that case, very slow process, Boyle's law will be holding. Okay, but if you are making faster process, so one piston cylinder cycle pumper you are taking, very fast you are pushing. So if you touch this cylinder wall, it will be very much heated up. Okay, so a very fast process. So temperature increased. You did not maintain this isothermal condition. So Boyle's law will not hold. So in that case, formula changes like this: PV power gamma equals constant. Okay, if system is faster, then PV or gamma. If the system is very slow, you are making isothermal. So, in that case PV equals C, fine. So, gamma value equals actually specific heat constant, gamma equals normally 1.4, that value you take, right, Cp by Cv. Okay, some values also you should remember actually, freezing temperature, boiling temperature, absolute temperature. C already know, centigrade 0 degree, 100 degree, F 32, 220, K, R. Okay, this table you should try to remember this specific value. Sometime you need. Okay, these are because absolute fixed value, so you should remember. Okay, already you may be knowing centigrade, Fahrenheit, but other you can use some conversion formula. You can directly convert or you can remember. So, many students will be trying to remembering things, many students will try to remember the formula so that they can convert any temperature to any temperature.